So this is question number 9.2, and the question says, is a 4.5 centimeter needle is placed at 12 centimeter away from a convex mirror, right? So a focal length 15 centimeter. Give the location of an image and the magnification. Describe what happens as the needle is moved farther from the mirror. Okay, so let's try this question, and here the answer is given in your board examination format. But before that, let's understand this question and the concept behind it. Okay, so this is your length, this is your mirror. Okay, there is convex mirror and the needle is placed here. The height of this needle is 4.5. Positive means it is above the principal axis, and negative means it is below the principal axis. If it is negative, if it is positive, it is above. If it is negative, it's below. Okay, that is for height. And what is for direction? If the direction that is taken here and always taken in the direction of incident ray, the direction is positive, is always taken for a sign convention. Okay, and also the opposite is negative, obviously, right? Now what you have to do is, first of all, you have written the given that section in your question answering format, right? Then after that, the first step that you have to do, otherwise you will get the wrong answer, is you have to put the sign convention with the value. So first of all, for object height we have 45 given needle, but this is with positive sign, that is above the principal axis, right? Second thing is the object distance, right? So object distance is your u, and that u, that is object distance, is given, is placed 12 centimeter away. Means from this mirror it is placed 12 centimeter away, right? This way. But this is not whole thing, you have to also add sign with it. So how you going to get the sign? So first of all, what you have to do is you have to go to the pole of the mirror, and then you have to go 12 centimeter away means this way, right? And 12 centimeter away, once you have reached, you have to see that in which direction you have went. You have gone in positive negative direction, right? So you have to add negative with 12, right? Understand? Then focal length is positive 15. How? So focal length is here, and you have to go 15 centimeter in this way, right? So I have drawn that a little bit shorter for the focal length. It has to be right here. Let me correct it. It has to be somewhat here. Okay, so this is your focal length, right? So this has to be 15 centimeter in the length. Okay, so this is the thing. But once you have done that, once you have seen that this is in the focal length is in this way, you have to start your the direction to measure the positive sign or the negative sign. You have to go to the pole, and then you have to start from there while going in the direction of image from here to the focus. And once you reach there, you will see that I have went for 15 centimeter away from the pole in the positive direction. So positive 15 you have to write for focus, right? So you have written focus with the positive sign here, 15 centimeter positive sign, right? Once you have done with the sign convention, you have to start solving this question, right? So for solving this question, you have to in the next step you have to use the mirror formula, that is 1 by v plus 1 by u is equal to 1 by f, right? Then you have to substitute the value in the place of u. You have to put the value that you have gained with the sign convention, right? You have put that minus 12, and then in focus you have to put that value that you have got here with positive 15, that is you have to put positive 15. Okay, then you have to do the simple calculation, and after doing calculation you will reach to the value with 6.67 centimeter for the image distance, and that is in positive 6.67. that means what? That in the positive direction, in the from pole, it is in the positive direction of 6.67 the image is forming. So it is not this way, but the image will be formed like this. The image will be formed like this. Okay, not this, right? Simple, understandable. Now once you have calculated the image distance, you have solved the half of the question, right? So image, that what the question has asked, the image is 6.67 behind the mirror, right? Now the second part of the question is magnification. So magnification m is equal to h dash by h, that is image height by object height, is equal to minus v by u, right? So you have to put, you know, v and you know u, you have to put the value 6.67, positive 6.67, and for u it is minus 1.12. Always put the sign, always remember the sign to put the sign in the right place, right? What you have calculated, and then you have to calculate m, and you have calculated m as m is equal to plus 0.56. Always put the sign plus 0.56. Now what is the positive sign significance of this positive sign? It means that the image is virtual and erect. If this is negative sign, it means it is real and inverted, right? So that is the theory you have to keep in mind. So here it is virtual and erect. Virtual means it is forming behind that image, right? So after that, here m is less than 1. M is less than 1. That means it is diminished. If it is greater than 1, it is magnified. So here it is diminished, right? Second thing is virtual means image form behind the mirror, right? Simple. This is the nature of the image that you got. And then effect of moving the needle farther from the mirror. So once you move the needle far from the mirror, you will see that the ray is converging at focus of that mirror. So when you move when you move the needle far from the mirror, the image will tends to form on focus and become smaller, right? So this is the third part of this question. I hope it is understandable to you, and it is very easy topic. And just you have to know the sign convention, and you have to put the value, and you know that what the sign convention or positive and negative means in different scenarios, right? Once you know that, it will be very easy to you, right? Okay.